In this video, we'll talk about adding and subtracting with scientific notation. So let's jump right in with an example. With mathematics, a lot of ways there are with a lot of things, there's multiple ways to do problems, and this is one of those cases. There's two main methods here. The first method is to convert into standard form and then add normally and then reconvert back into scientific notation. So if we were to do that, we would convert this, we move the decimal over 6 places. This would be the same as 320,000. And then I do the same thing with this 2.1 times 10 to the 6, and this would be 210,000. Now, since we have the same power of 10, the addition is made a little simpler for us. So we can add, we can just make sure we line up our zeros. We have to be very, very careful about this. Make sure our decimals are lined up. So 0 plus 0 makes 0, 0, 0, 0. 2 plus 1 makes 3, and 3 plus 2 makes 5. And then I'm going to convert this back into scientific notation. So we want to move the decimal over, looks like 6 places, so we're going to have 5.3 times 10 to the 6th power. There's one method. The other method is that we kind of keep the scientific notation. So if we look at what this is really saying here, 3.2 times 10 to the 6th power plus 2.1 times 10 to the 6th power. If we think about this, our powers of 10 are the same, meaning that we can essentially rewrite this as 3.2 plus 2.1 first, and then multiply the sum of those times 10 to the 6th. It's kind of like reverse distributive property. It ties back to the idea of if you have 5 times 2 plus 5 times 3, well, that'd be the same thing as 5 times 5. Same kind of idea. It's repeated multiplication or repeated addition. So since we have this repeat, since it's the same power, we can just add our decimal numbers, which becomes 5.3. And then we have times 10 to the 6th, which is exactly what we got when we converted to standard form and then traced it back. So this is two methods of doing the exact same thing. If we're adding or subtracting, we need to make sure that we have the same power of 10 if we're going to maintain it with this second method. Let's take a look at an example where we don't have the same powers of 10. So, again, two methods. We could convert them into standard form first. So we have 2.3 times 10 to the 9th, so we have 2, 3, and then we have to count 8 zeros behind that to represent our 9 places. So 1, 2, 3, 4, 5, 6, 7, and 8. Now we have to do something very similar with this 5.1 times 10 to the 7th. So we know that we're going to have 6 zeros behind the 1. So we have to, again, be very, very careful with lining up our numbers. 1, 2, 3, 4, 5, 6, and then we go 5, 1. Now we can do the subtraction, and we have to be very, very careful about it. So 0 minus 0, that makes 0, so we have 0, 0, 0, 0, 0, 0. Now I have to borrow. So I'm looking at this column, I can't take 1 from 0, so I have to look over again. I have another 0, so I got to look over here. That's going to become a 2, then we have a 10, makes a 9, then we have 10. So we have 9, and then 9 minus 5 makes 4, and then our 2 and our 2 come down. Which then if we reconvert back into standard form, it's going to be 2.249 times 10 to the power of, looks to be 9. And that would be how we could do it with our standard form. Now, the issue with that is that we have to be very careful lining up our decimals. We have to be very careful with our subtraction. And generally speaking, it takes a little bit of time and discipline to do so. If we look at this in terms of scientific notation, though, we can adjust our bigger one. So if I was to allow this to go down to a power of 7, I could move my decimal over 2 places to the right. So this would be the same as 230 times 10 to the 7th. It's not scientific notation, but these two expressions are equivalent. If we expand them out, we would both, or they both would be this yellow number that we got when we expanded to standard form. And then I can just keep the 5.1 as is. And instead what I can do, instead of doing this really big, huge number that I have on the left here, I can take 230 minus 5.1, and then whatever I get from that, take that times 10 to the 7th. It can help save me some work. I don't have to deal with all these decimal places. I only have to worry about a few. So if we go 230 minus 5.1, again, we have to be very careful just lining up our decimals, but there's much, much fewer numbers to work with here. A lot less on the digits. So then we come over, we got to borrow still, and then we go through. So we get 9, and we get 4, and 2 and 2. And then we have times 10 to the 7th. Now again, this isn't scientific form, so we have to bring over the decimal 2 places, and if I do that, that means this power's got to go up. So we have 2.249. We move it over 2 places, so that means my power goes from a 10, or from a 7 to a 9, and we get the same thing. Now, it's worth noting, we can do this because we made the powers the same, so we can convert them. We can move decimals over and adjust our powers accordingly. It might not make them scientific notation for a minute, but then once we're done, we can just add or subtract a much simpler difference or sum, depending on what we're doing, instead of trying to turn it all into huge numbers and try and be very careful with our zeros. So, choice is yours. It's just 2 ways of doing the exact same thing.